Welcome to The Explainer. Today we're taking a really fascinating look at the invisible mechanics of the internet. We're going to break down System Design Day 4, Networking Fundamentals. You know, if you've ever felt completely overwhelmed by that massive alphabet soup of network protocols, well, you're definitely in the right place. Okay, let's dive into this.
So, I want you to imagine, just for a second, the exact moment you type a URL into your browser and hit enter. I mean, it feels basically instantaneous, right? Boom, it just pops up on the screen. But behind that simple, everyday keystroke is this massive, incredibly complex set of mechanics, all firing off in mere milliseconds. So what actually happens in the background to get that web page onto your screen?
To answer that, here's our roadmap. We're going to follow a single web request from start to finish. First, the client and server. Second, finding the destination. Third, choosing the transport. Fourth, securing the conversation. Fifth, understanding network latency. And sixth, tracing the full journey.
Section 1. The client and server. The core relationship.
To truly grasp networking, you really have to frame the entire internet as this giant, never-ending conversation between two distinct entities. We operate on what's called a client and server architecture. So your local browser, that's the client requesting resources, and the server is the distant machine providing them. It sets up this foundational request and response dynamic. You ask, it provides. It's that simple.
Moving on to Section 2, Finding the Destination, IPs and Ports.
Now, you might be wondering, in a network of literally billions of devices, how does the client locate a specific server? Well, it uses its IP, or Internet Protocol Address. You can basically think of this as the server's exact street address. Every single connected device has this unique numerical label. And this brilliantly illustrates how global infrastructure can route traffic accurately across oceans instead of just, searching blindly in the dark.
But here's the catch. Just getting to the street address isn't quite enough. Think about it. When you arrive at a massive apartment building, you still need to know which door to knock on, right? And that's exactly where ports come in. Ports are virtual endpoints that help the receiving computer sort out incoming data. If the IP address is the building, the port is the specific apartment number. It ensures that when your data finally arrives, it goes to the correct application, like, say, a web server on port 443, instead of accidentally stumbling into an email server.
All right, Section 3, Choosing the Transport, How Data Travels.
So, once we know where we're going, the data has to travel, and it travels using transport protocols. The two major players here are TCP and UDP. Now, TCP is like your highly reliable, meticulous courier. It checks for errors, guarantees delivery, and ensures your data arrives in the exact right order. It takes a tiny bit longer, sure, but it is flawless. UDP, on the other hand, that's the incredibly fast fire-and-forget alternative. It just streams data constantly without stopping to verify if you received every single packet. So, while TCP is absolutely perfect for loading a web page where every single line of code matters, UDP is the protocol of choice for things like live video gaming or VoIP calls, where sheer speed is prioritized way over perfection.
Section 4. Securing the Conversation, HTTP, HTTPS, and TLS.
Now, what's really interesting about this is that once we know how data physically travels, we have to look at the language the devices are actually speaking to each other, and crucially, how to keep it secure. Here we have HTTP, which is the foundational plain text language of the web, and HTTPS, its secure counterpart. Sending data over HTTP is literally like writing a password on a postcard. Anyone on the route can just flip it over and read it. Not great. HTTPS, however, encrypts the transfer, making it look like absolute gibberish to any potential interceptors.
So how does HTTPS actually pull off that encryption? Well, through TLS, or Transport Layer Security. This is the actual cryptographic magic behind the S in HTTPS. When your client and the server connect, TLS uses some really complex mathematics to just completely scramble the data. This is absolutely crucial because it ensures that your passwords, your credit card numbers, and your personal messages remain entirely private as they travel across the globe.
Section 5, Understanding Network Latency, the Wait Time.
Okay, so with all this routing, traveling, and heavy encryption going on, obviously this digital road trip isn't perfectly instantaneous. Network latency is the time it actually takes for a data packet to physically travel from its source to its destination. I mean, even when moving near the speed of light, bouncing through all those hardware routers and crossing vast geographical distances, it takes a toll. So the crucial point is that geography and hardware actively impact speed. A server all the way in Tokyo is naturally going to take longer to respond to a client in New York than one sitting right across town. It's just physics.
Finally, Section 6, Tracing the Full Journey. Practice.
Let's move to this chronological sequence and see how this builds together into one cohesive story. This is the incredible micro-story of every single web request you make. Step 1, your browser, the client, initiates the request. Step 2, the exact street address and door, the IP and port, are located. Step 3, a reliable TCP transport connection is established between you and the server. Step 4, TLS jumps in to mathematically secure and encrypt that connection. Step 5, your secure HTTPS request is finally sent, and the server responds with the data. And then, Step 6, your browser takes that raw code and visually renders the website right on your screen. It's amazing. All of those intimidating networking acronyms we just covered, they're actually vital sequential steps happening literally in the blink of an eye.
You know, understanding this structure completely transforms how you look at the internet. It really makes you appreciate the massive, invisible infrastructure we rely on every single day. So, I'll leave you with this final, provocative thought. Next time a page is loading slowly and you're experiencing that dreaded network latency, ask yourself, where exactly did your data get stuck? Was it finding the IP? Was the TCP handshake delayed? Or is it just physical geography? Thank you so much for learning with me on this explainer today. Keep exploring, and I'll see you in the next one.